Hey everybody, and welcome back to Algebra 2 Online. So last class we talked about those complex numbers, and I introduced imaginary numbers. For class today, it's really just going to be time to work on some mixed kind of quadratics of all different types. And I wanted to show you a problem like this. So this looks kind of big and scary, but it ends up actually being fairly nice. If you actually graph this thing on the left here in like Desmos, you get this thing, which looks kind of weird. And we want to know when it equals 0. And we can see there's like two spots here, right, where it equals 0. And I'm just going to show you kind of how this actually becomes a quadratic, because it really is a quadratic problem, and talk a little bit about what's happening here. So one thing that I would do if you ever see something like this, right? This is a difference of perfect squares. I'll write it again. Difference of perfect squares. I would always just factor it because there's a good chance that that can help simplify some stuff. So I'm just going to copy down a lot of this. Okay. And one thing that's nice here is you have on the bottom, there's a lot of common factors, right? The common denominator of this thing is x plus 2, x minus 2, which is the denominator for this one, right? So if we multiply both sides of this thing by that common denominator of x plus 2 times x minus 2, we should be able to simplify a ton of stuff. Like, x minus 2 cancels with that one when we multiply, so we would just have negative 5 times x plus 2. When we do the second multiplication, it cancels that one, but not this one. So then we have x minus 5 times x minus 2. And then this last one's really nice because here, these both cancel with these two things, like when we do this last multiplication. So then we just have 3x plus 8 left over from that one. And then 0 times that, common denominator is still 0. And if you look at this thing, this is now actually a quadratic problem. And it's really just because of that term right in there. So I'm going to go through and just like multiply everything out, just like distribute everything here. A lot of like terms to combine. I'm going to stick my x squared at the front. I like to like cross these off as I go so I don't lose track of like terms and all that. So this is minus 10, minus 12, plus 3 is minus 9. And this is nice. Those cancel, and then you just have an 8 left over. And then this is actually a nice quadratic because it's going to be one that can factor. So if you do x minus 8 and x minus 1, right, you can get the factors, right? And it's just like I'm checking really those cross terms again. So negative 1 minus 8 is negative 9. This is just kind of a nice one. And then you can see the answer. So, what here do you plug in and get 0, and that's 9. And then what here do you get? Do you plug in and get 0, and that's 1. And so those two things are my solutions. And it's hard to see, but this is actually like where the 9 is in there somewhere. And then the 1 is, it's not 9, it's 8. I don't know why I said this is 8. And then over here is the 1. This is actually something we will study some more this year. This is actually called a rational function. But I like showing them now because there are actually a lot of rational functions become quadratics. Rational function gets its name because the function looks like a ratio. So ratio meaning like you have something up here divided by something down here. And that's like the ratio. So basically they're they're equations and they're functions that have fraction structure to them. So variables on top and bottom or something, or just on the bottom. The variable has to be on the bottom to be a rational function. Like if you have x over 2, that's a linear function. So it needs to be x is on the bottom at least. And rational functions have these weird graphs like this. There's some weird stuff going on actually at 2. So if you plug in 2 here, right, you would get 0. And that's one of these asymptotes that we have talked about before. So there's an undefined spot at 2. And then there's another one over here at -2. And that's this right here. So the graph actually kind of has 3 disjointed parts. And it is, it's something we study a lot more in depth later on, but a lot of those problems really are just quadratics at their core. So I wanted you to see one right now. And there are a few of these on the mixed quadratic practice. And these are kind of, I think, the hardest ones. But basically the idea, if you see the fractions like this, just get a common denominator, multiply through by that common denominator, and then you'll be able to cancel a lot of stuff because you're just multiplying both sides by the same thing, but it makes it easier like this. And then it'll just be combining like terms and actually a lot of them, even on the homework factor and stuff.